Hey guys, so we're on lesson 6 for today, and we're going to be talking about writing algebraic expressions. So expressions again means it's numbers and variables and symbols, but no equal sign. Algebraic means it involves variables. Okay, so how do we do that? So how to write algebraic expressions. Now you're like, hey, didn't we just write that? Yeah, we kind of did, sorry. All right, so how do we do it? Number one, believe it or not, starts with reading. So we're going to read the phrase in English. Okay, and I would suggest at least 2 times. So when I read a word problem or any kind of phrase or sentence, I read it through once just to kind of get the gist of what's going on in the problem, and then the second time I start kind of picking apart all the pieces of it. Okay, so one thing that's going to be true is there's going to be something that we don't know about, an unknown. And so we're going to identify the unknown. So it's going to be some words that I can't translate into a number or an operation. So I'm going to say here it's not a number or operation. Now, interestingly enough, most of the time it is the phrase a number. Okay, so a number is going to be the unknown. We don't know what that is, so he is going to be a variable. So I'm going to teach you a phrase that if you learn it now, life will be so much easier. And that's called define the unknown, and sometimes I'll say define the variable. So once we isolate the words that we don't know how to translate, we're going to choose any letter to represent the unknown. Sorry, any. To represent the unknown words. So again, everything in a word problem is going to be, we're going to be able to take it and turn it into adding, subtracting, multiplying, or dividing. And numbers, and then whatever we can't change, that's going to be the unknown. So you're going to explain in words, that's what a definition is. So we're basically going to take the actual words from the problem, and we're going to use that as part of the definition. So explain in words what the variable represents. Okay? And you need to be specific. I'm going to try that again. That looks terrible. Be specific. So like, for example, let's say you're trying to figure out Joni's age. So if you just said years, what does that mean? If you just said age, whose age? Okay, so be specific. Then we're going to do what's called translate. So if you're in a foreign language class, you take the words you see in English and you translate them into the foreign language or vice versa. So for us, we're going to translate the English into numbers, operations, and variables. So remember, operations just means adding, subtracting, multiplying, or dividing. variables. So that's going to be the we don't know what you are. Okay? All right, so you probably can stay on this page to continue the next piece, but I'm going to need to go to the next screen, so give me just a second for that. Okay, so we're going to come up with words that mean operations. So they're going to tell me to add, subtract, multiply, or divide. So what we're going to do is kind of create a chart. We're going to talk about words that tell me addition, words that mean subtraction, words that mean multiplication, and words that mean division. Now remember, you can slow down the video if you feel like I'm going too fast so that you can hear things more clearly. You can take breaks, you can put on pause, write things down, whatever you need to do, but it's good to listen to the video as well. So let's start with words that mean to add. So I'm not going to get all of them. I'll be honest with you. It's impossible to get every single word because there's so many variations of some key ones. So this is a good sampling though. Plus, that's pretty obvious. Total generally means the addition problem. Altogether, that's kind of a giveaway. More than, but more than is a little special, so I'm going to put a star by it. We'll talk about that special star in just a little bit. Some, the answer to an addition problem. Sorry if you hear some weird noises. It's my cat walking around. So what you just read. Sorry. She keeps stepping everywhere on my bed and on my computer. Dumb cat. Good thing she's cute. Okay, let's try this again. So some added to, and that's also going to get a star, and increase. So again, more than is one of those strange words that mean you could have more than, greater than, taller than, faster than. So there's a whole lot of variations of that. All right, let's talk about words that mean to subtract. Less than. So he's also going to get a little star. And then minus. The answer to a subtraction problem is a difference. So sometimes you guys say, well, what does it mean? What's the difference? And then you start thinking about it like in English, like a Venn diagram. But no, it means to subtract. Takeaway. Subtracted from. That also is going to get a star. Diminished. It's kind of an old-fashioned word. Diminished. I like it though. And decrease. Okay. Multiplication. Now what gets interesting about multiplication is that some of the words don't mean just to multiply. They mean to multiply by a specific number. So times is probably the most popular way they let us know we have a multiplication problem. The answer to a multiplication problem is a product. We've already seen in prior chapters that the word of means to multiply. And then, just for an example, twice or double doesn't mean just to multiply, it means to multiply by 2. Okay, and then you could have triple as well, multiply by 3, and so on and so forth. But we could be here all day coming up with examples. The last is division. Quotient, that's the answer to a division problem. Divided by, some of them are pretty darn obvious. Split into equal groups, that's a mouthful. So usually grouping gives it away. In each group, see, here's group again, right? Oops, why did I do a Q? There we go. In each group. Per, we talked about that in chapter 2. Ratio, we talked about that in chapter 2. And divided into. It also gets a star. So again, not an exhaustive list. There's a lot more to come. So, remember all those stars? We're going to explain that those stars are words or phrases that switch order. So I refer to those as switcher phrases, okay? Switcher phrases. So if you're saying, I have 6 more than 12, well, think about it. You started with 12, and now you're going to add 6 more. 2 subtracted from 7, well, I had 7, but I'm now going to take 2 away from it. So the first number is actually coming after the operation. It's kind of strange. Switcher. So the ones we had here were more than and all of its cousins. That tells us over addition we're going to switch the numbers. Added 2. 5 added to 20. 20 is what I started with, and then I'm going to add to it. We've got less than, and all of its cousins. Fewer than, shorter than, younger than. That's a subtraction. Subtracted from. So it's these particular pairings. Oh, subtraction, and I didn't even write this the whole thing. Let's try that again, shall we? Subtracted from. That's subtraction, and divided into. So 2 divided into 12 is 6. So 12 is what we started, and then we divided it by 2, and that gave us the 6. Okay? Now, we also have these things, these phrases that mean parentheses. So words / phrases that mean parentheses. Okay, and what's interesting is you'll hear the phrase first, and then you'll hear like 2 and 7, or 5 and a number. And what they're telling you, those are the 2 numbers that you're going to do this operation with. So the 3 most common ones are going to be the sum of, so these 3 words together, and then we'll say like 2 and 5. That means you're going to have a number, you're going to add, and then you'll have another number. That's not hashtag, sorry kiddos, that means number. And then there's the difference of, so it'd be the difference of 12 and 4. And basically you would have the number that they mentioned first minus the second number. So the order they list the numbers would be the order you write them. These are not switcher phrases. They're just saying you got to put the parentheses. So generally speaking, the reason why we use these parentheses because there's another word that comes in front of it that affects both of those numbers. And you'll see that in an example. So the quantity of, and then that could be any operation. So you have this, and it's usually adding or subtracting it'll say the quantity of 6 and plus 2 or whatever. So again, it's going to involve two numbers that they give, it's going to have an operation, and so on. Okay? So I would suspect at this point you are at the end of your page. Maybe you've already gone over. Some of you are pretty big writers, I've noticed. And now we're going to get into some examples. So I'm going to suggest that you actually write out the problem in the words in your practice spiral, and then kind of do the same thing I'm doing. It's kind of like diagramming a sentence where everything has a role to play. So it says, write each phrase as an algebraic expression. So in every one of these, we're going to see some words and that's going to be the unknown algebraic expression. Okay? All right, so first one, $10 less than the original price. Okay, so the first thing I'm going to look for is numbers. I'm going to look for some numbers. So number-wise, $10. Now, generally speaking, when we're translating, we tend not to put any labels in, okay? Because we don't put a label in until we get to the answer, but we need to understand when we do our problem that 10 represents dollars. And then it says less than. So these words are kind of interesting because not only do they tell us to subtract, but they're also whatever comes in front of the word less than is going to go after the subtraction symbol because that's what less than means, and then whatever words come after less than are going to get picked up and put in the front. Now, the original price, I cannot turn it into a number or an operation, so that is our unknown. So we're going to have to define it. What does that mean? Pick a variable and then write the words that it represents. The original price. Okay? So now when I translate, I have to remember this switcher phrase is going to change what was in front to go in the back and what was in the back to go in front. So what keeps them apart is the subtraction. So the 10 or $10 is going to go in the back and the unknown is going to go in the front. So this would translate into x minus 10. But I need to include both of these in my answer. The definition of what the variable represents and then the translation. All right, here's another one. Gets a little bit more. $3 more than 4 times the cost of a pretzel. Okay. So numbers are pretty easy to identify, right? Those are pretty darn easy. And let's see, what do we have for numbers? 3, 4. Okay. Look for the operation. I see, uh-oh, more than. So everything that comes in front is going to get switched, not just with the thing that comes directly after, but everything that comes after. Boop. Okay. Forgot to put this guy here. Now, there is another operation here. Not only do we have more than, which means to add, but we also have times, which I'm going to use the dot version. Now, the weird thing is that last phrase, the cost of a pretzel. I don't know what to say, so that is the unknown. So I'm going to pick a variable, and I just got to tell you, my 8th grade algebra teacher always used x, so I just got trained with that. And I'm just going to write the words. The cost of a pretzel. So here's the thing. Every single word is going to get turned into something else. Okay? All right. So what it says is 4 times the cost of a pretzel is going to come in the front. So I'm going to write 4 and then times, and remember what we talked about in the last set of notes is that if I put something butted up to a variable, so a number butted up to a variable, what we might not see is this means times. So if I don't see the operation, it's always multiplication, okay? And then it said we had the more than, okay, and then the 3 would go in the back. So 4 times the cost of the pretzel, we would have $3 more than that, okay? So we'll box up both of those. Actually, I'm going to go with black. Pink kind of fades into the answer. We got one more and then we're done. Sorry, these are a little bit longer. All right, 12 times the number of feet. So first thing I look for are actual numbers, so 12. And then I look for what means math, and I have times, so that's going to be there. And then the number of feet. Well, that's not a number, and that's not an operation, so that's going to be my unknown. All of that. So everything is being accounted for. So I'm going to take my variable, and I'm going to write out the words it's going to take the place of. The number of feet. Okay, so no switch or phrase this time. So I'm going to have 12 times the number of feet. So it would just be 12x. And remember that this means the same thing as 12 times x. Okay? And there we go. Let me just box that up, and we are done. All right, good luck, guys, and we'll be going over this. Bye now.